So here's part 2 of our solving thermochemistry using stoichiometry. The question may not give you the enthalpy of the reaction, but it might give you specifically 200, for this example, 241 kilojoules of energy is released when 15.5 grams of glucose is burned. And we want to know what's the enthalpy of combustion for this reaction. So again, start by listing out the information that we know. In this case, um, the energy, the enthalpy of the reaction, I still want to put that as a term, and it's a combustion reaction, so it's going to be on the product side. But the overall enthalpy is unknown, so this becomes X kilojoules of energy. So we're still putting the energy as a term in the equation, but we actually don't know specifically what that value is. I do know that for this specific reaction of 15.5 grams that I produced 241 kilojoules of energy. The mass of glucose that was burned was 15.5 grams, and my molar mass of glucose is 180.18 grams per 1 mole. So we're still going to set it up the same way. I start with my known, which is my glucose, and I've got 15.5 grams of C6H12O6, and we'll just write that over 1. I want to cancel out grams and convert to moles of glucose. So I'll use my molar mass here. So I've got 1 mole of glucose for every 180.18 grams of glucose. And grams of glucose will cancel. At this step in stoichiometry is where we'd use our mole ratio. Because my energy is unknown, I'm going to say that this guy is going to be an X. I don't know what that coefficient is. And then I have 1, so the coefficient of glucose is just a 1, mole of C6H12O6. Moles of glucose cancel. What I do know is that the energy released when I burn 15.5 grams of glucose is 241 kilojoules. So this is equal to 241 kilojoules of energy. Now what I want to do is simplify this so I can solve for x. And what I want to do is multiply 15.5 by 1 over 180.18. So when I do that, I get a value of 0.0860. This is times x over 1. So in this case, I canceled out moles of glucose, so it's just x over 1. If the coefficient was anything besides 1, we'd have to include that here. But in this case, we don't need to include the 1. So this becomes 0.8602 times x equals 241 kilojoules. Solve for x, we just divide both sides by 0.08602. So when I divide 241, divide by 0.08602, I get an x value of 2,801.7 kilojoules. And if we jump back to our previous problem that we looked at, part 1 of these videos, this was the enthalpy for the combustion of glucose. So our answer is spot on where it should be.